Good morning everyone. Today our team will talk about area and volume. Area means measurement of the surface or region covered by two-dimensional shapes. It quantifies the amount of space enclosed within the boundaries of the shape. Volume means measure of the amount of space occupied by a three-dimensional object. It quantifies the capacity or extent of a solid figure in three dimensions. Area and volume are fundamental concepts in geometry that helps us quantify the size or extent of two and three-dimensional shapes, respectively. They are essential for a wide range of fields, including mathematics, engineering, architecture, physics, and more.
Hello everyone, I'm here to explain about area under the curve. What is area under the curve? The area under the curve means the area bounded by the curve, the axis and the boundary point. Furthermore, how do we find the area under the curve? The area under a curve between two points is found out by doing a definite integral between the 2 points. To find out the area under the curve y equals to fx between x equals to a and x equals to b, integrate y equals to fx between the limits of a and b. This area can be calculated using integration with given limits. Moreover, the area of the region above the x-axis is positive, while the area of the region below the x-axis is negative, as you can see in the diagram. And the area of region in the right of y-axis is positive, while the area of region in the left of y-axis is negative, as you can see in the diagram also. This is a side note for this area under the curve. That's all for now. Thank you.
The volume of a region refers to the amount of a space occupied by that region in three-dimensional space. It is a measure of the capacity or extent of the region. To understand how the volume of region is calculated, let's consider a simple example of a rectangular box. In this case, the volume of the box can be calculated by multiplying its length, width, and height. The formula for calculating the volume of a rectangular box is volume equals to length multiply width and multiply height. This formula applies to regular shape like cubes, rectangular prism, cylinders, and so on. For a regular shape or region, determining the volume can be more complex and may require different approaches.
Area. Find shaded area of the following figure. Example. That is my graph. That is y equal 3 square root x, and here is my solution. Shaded area equal integrate for 1 y dx equal integrate for 1 3x 1 per 2 dx and equal integrate 3 times 1 per 2 dx equal 3 times integrate x 1 per 2 dx and equal 3 times 2 square root x times x per 3 and equal 2 square root x times x 2 square root x times x integrate for 1 equal to square root 4 times 4 minus 2 square root 1 times 1, and the final answer we got is 14. That is for my answer for area. Thank you.
Find the area under the curve when y equals to x squared minus 2x plus 8 from x equals to 1 to x equals to 2. To draw the graph, we should grab the equation y equals to x squared minus 2x plus 8 as the keyword. When x equals to 0, we will get y as 8, and we have done some calculation to get the vertex, which is 7. By doing this, we can draw the graph. As you can see, we have drawn the graph, and now we are going to find the area underneath the curve. Therefore, area or A equals to integral 1 to 2 and in bracket x squared minus 2x plus 8 close bracket dx. Now we have to differentiate x squared minus 2x plus 8. For that, we will get x cubed over 3 minus 2x squared over 2 plus 8x. As the next step, we can simplify the equation by cutting 2 over 2. So now the equation will be x cubed over 3 minus x squared plus 8x. After this, we can substitute the 2 and 1 in the equation. As you can see, we have substituted the 2 and 1. By calculating, you can get the answer. And the answer is 7.334 units square.
Example 1. Find the value of the volume that is obtained when the shaded region is rotated 360 degrees at x-axis. Solution. Volume generated. Integrate 1.50 pi y square dx equals to integrate 10 pi in bracket x square dx plus integrate 1.51 pi in bracket negative 2x plus 3 square dx equals to pi integrate 10x the power of 4 dx plus pi integrate 1.51 in bracket 4x square minus 12x plus 9 dx equals to pi in bracket x the power of 5 over 5 integrate 10 plus pi in bracket 4x cubed over 3 minus 12x square over 2 plus 9x integrate 1.51. Then we replace dx with 1.5 and 1. So equals to pi in bracket 1 the power of 5 over 5 minus in bracket 0 plus pi in bracket 4 in bracket 1.5 cube over 3 minus 6 in bracket 1.5 square plus 9 in bracket 1.5 minus in bracket 4 in bracket 1 cube over 3 minus 6 in bracket 1 square plus 9 in bracket 1 equals to 1 over 5 pi plus pi in bracket 4.5 minus 13 over 3. So the answer we get is 0.367 pi or 1.153 unit cube.
Find the value of the volume that is obtained when the shaded region is rotated 360 at y-axis. Formula of volume of revolution is integrate 1 negative 1 pi x square dy. So it will be pi integrate 1 negative 1 bracket y square plus 1 bracket 2 dy minus pi integrate 1 0 y square dy. And then we develop bracket y square plus 1 bracket square and we'll get bracket
Y the power of 4
plus 2 y square plus 1 bracket pi bracket y the power of 5 per 5 plus 2y the power of 3 per 3 plus y bracket 1 negative 1 minus pi bracket y the power of 3 per 3 bracket 1 0. After integrate, we put the value in y and calculate all the value. After we calculate, we will get 56 per 15 pi minus 1 per 3 pi. We will get the answer 17 per 5 pi unit the power of 3. Our conclusion for this presentation is area and volume refer to the final results obtained when determining the surface area and volume of a three-dimensional object or shapes. These calculations are essential in various fields such as mathematics, physics, engineering, and architecture. In summary, the conclusion area and volume are the final results obtained when determining the surface area and volume of a three-dimensional object, respectively. These conclusions are crucial for understanding and quantifying the characteristic and special properties of various objects in mathematics, physics, engineering, and other related fields.